So hello everyone, my name is Akash Malik and in this video we'll discuss the second lecture of electrostatics. Okay, so basically we'll do the questions based on Coulomb's law. So basically I'll do the question which was quite similar to what we did in the last class. Okay, which I gave in the last class basically. So you'll get an idea of how to solve that question. So because that was a kind of hard question, before that you must do some easy questions. All right, so the question is like this: is q, its coordinate is minus a comma 0, and this is plus q, same q only, and coordinate is a comma 0. So I'm saying I'll put up charge over here, this q only over here, and you can see that the net charge acting on this force will be what, 0 only. Okay, so what I'm saying that I'm shifting this charge a little bit over here, okay, at a distance x, let us say. Okay, so I'm asking what will charge do. So answer to this question will be that this charge, when we shift over here, okay, so the I'm gonna draw the FBD will be this force 1 and this will be force 2 over here acting on this. Okay, so I can say that this F2 will be greater than F1. Why? Because this R2, let us say this is what, R2. So this R2, the next A minus X, basically that is R2 is less than R1. Okay, so I can say this. So when I just shift it over here, it will experience a net force over in this direction. So it will try to go this on this side. So when it will come over here, this force will become dominant and it will exert a net force over here. So it will try to do an oscillatory motion. So the answer to this question is that the charge will perform oscillatory motion. Now my question is that this motion, is the motion SHM? My next question is this motion SHM? So you can't directly answer this because for the condition of SHM is that F should be proportional to minus x square basically, right? So F should be proportional to minus x, and that is we don't know yet. Okay, so we will calculate this. Okay, we will calculate this. How we will calculate? Basically, I'm gonna write this F net, and that we know is what, F2 minus F1. Okay, so F2 minus F1 will be written as this K Q square. F2 is A minus X whole square minus K Q square, and this F1 will be A plus X whole square. Okay, so now what I can say is KQ square, and it will be a square plus x square plus 2x minus a square minus x square plus 2x. So it will be 4ax over a square minus x square ka whole square. Okay, so I hope you don't have any doubt till here. So now we'll move to our next part of the calculation, that is this. For SHM, let me give you here a condition. Okay, I am giving you a condition in the question itself. Okay, the condition is that this x is very less than this a. Okay, this x is very less than a. So if x is very less than a, so this f net can be written as k q square over a raised to the power 4 multiplied with 4ax. All right, how can I write it as this? Because this a square will be very greater than this x square, so a square minus x square can be written as this. A square minus x square can nearly be written as a square only. Okay, if this condition is true, so we have this. So 1a gets cancelled out and we have kq square upon a cube into 4 basically into x. So this force is opposite to the direction of motion. Okay, how can I say that? Because the motion of this charged particle is in this direction. This direction is what motion, and the net force is acting in opposite direction. So I can say that this force is negative, and it will be equals to what, ma. So a can be written as 4k q square over a cube multiplied with m and a negative sign and x. So for SHM this would be this must be equals to minus omega square x. So we have this omega as 4k q square upon a cube into m and power 1 by 2. So in this case this is SHM because it is proved the force is indirect this proportional to minus x. So the time period will be what, 2 pi by omega. So in this case the time period will be what, 2 pi into root over m a cube over 4k q square. So I hope you don't have doubt up till here. Now we'll move to the next question. Okay, we'll move to the next question. So the question says that basically we have this liquid. Okay, some liquid, I don't know what liquid. It could be water, it could be oil, it could be kerosene, anything. And we have this string basically, and we have a charge particle over here and a charge particle over here. Okay, so the length of the string is L. Okay, so and I'm asking this theta. Okay, this theta is basically given, and the charge is q and the mass is m, and the density of the liquid is rho, and rho L. Okay, and the density of this ball is rho b. Okay, this rho b. So I'm asking you that what is the value of theta? If theta is very less than 1. Okay, so this is my question to you. So we'll just solve it. I hope just pause the video and solve it. If you are not able to solve it, just wait and watch. So first of all, you see, we'll take only one ball. We'll draw the FBD of first ball only, and this is its weight. Okay, mg. Okay, this is weight. This is the tension in the string. Okay, this is the tension in the string. If this is theta, this will also be theta, and it will be what, the force of electrostatic. Okay, and if it is present in a liquid, we have a force of buoyancy over here. I hope this is clear. So now if this is an equilibrium, all right, this is an equilibrium. So in equilibrium, okay, what I can write is we can balance the forces. So T sine of theta can be written as what, Fe, and T cos theta plus this force of buoyancy can be written as mg. So basically this is a simple question. I'll just substitute T as Fe by sine theta. Okay, and I'll just put it in this equation. I will get this Fe into this tan of theta will be equals to mg minus force of buoyancy, and tan theta will be equals to mg minus force of buoyancy over this force of electrostatic repulsion. Okay, I hope this is pretty much clear. Now I'm gonna write the values of this FB. Force of buoyancy is rho of liquid, density of liquid, multiplied by the volume of the submerged body. Volume of the submerged body, that will be mass of the body divided by volume of the body. So mass is m, and this density m by v is what, density. So volume would be m by d. So it will be rho of body multiplied with G. Okay, and this force of electrostatics repulsion, it will be 1 upon 4 pi epsilon naught q1 or q square, basically both are same. So q square over this distance whole square. It is what, L sine theta. Okay, so it is this is what, this is, let us say, x. So it will be x by L is equals to sine theta. So x is equals to L sine theta. Okay, so it will be x square, not x square. It will be what, 2 4x square, 2x ka whole square. Okay, so I have fe and fb, and now I'll just simply put it in this value, and then I'm gonna calculate. So you might be getting confused. Then when you'll write this fe, it will be L sine theta whole square in this numerator. So what you have to do, I have given this condition that theta is very very less than 1. So I can write, when theta, if theta is very very less than 1, I can write tan theta as nearly equals to sine theta. So that is a important concept you must have studied in chapter trigonometry, or if you are a dropper, you must have studied in limits also. The proof is in limits. Okay, limits, continuity, differentiability, that is LCD is a chapter. So you have studied it in limits.